Assalamualaikum warahmatullahi wabarakatuh, and hi, we are from Group 7 and we gonna presenting about our visit to FKMP UTHM Biodiesel Plant taking part at 27 November 2025. So, my name is Hilmi bin Halim and my matrix number is AA240320. Now, let's get started. Now, this is our group member that taking part in our group project. Now, in our presentation, we're going to talk about the introduction, plan overview, FKMP biodiesel plan description, thermodynamic application in the plant, and equipment and processes, safety and environmental consideration, and lastly is challenges and innovation. Now, let's start. This academical industrial visit was carried out to give students a real exposure to an actual industrial environment related to engineering applications. Through this visit, students were able to see how theories learned in classes, especially in thermodynamics, are applied in a real production system. The visit also helps students to understand how industrial plants operate on a daily basis, including the use of equipment, procedures, and environmental practice. Overall, this visit provided a clearer picture of how engineering knowledge is used in the industry and helped students prepare for a future professional work. So, what is the objective of the visit? The objective is to observe a real industry equipment used in engineering process, to understand the sequence of processes involved a planned operation, to relate thermodynamic concepts learned in classes to actual industrial applications, and and then to learn about safety practice and environmental management in the plant. And lastly, to gain exposure to engineering work culture and career opportunities. So for the next part is plant overview. The plant function as a training-based industrial facilities that allows students to observe the real engineering system in a controlled and safe environment. Is it designed to simulate actual industrial operation while maintaining a scale that is suitable for academic learning and research activity. The, the facilities integrates mechanicals, thermals, and process equipments to demonstrate how engineering principles are applied in a real production system. Through these setups, students are able to understand how different units work together as a complete system rather than as individual components. In addition to its operational role, the plan supports sustainable engineering practice by emphasizing efficient energy usage and proper process control. Parameters such as temperature, pressure, and flow rates are monitored to ensure a stable and efficient operation. The plan also provides exposure to standard industrial practice, including equipment layout, process flow arrangement, and basic operational safety requirements. This makes the facilities a suitable platform for students to relate classroom theory to a real-world engineering application in a practical and a meaningful way. Now to the next part, which is FKMP biodiesel plan description. The FKMP biodiesel plant is an educational and research facilities located at the Faculty of Mechanical and Manufacturing Engineering (FKMP), University Tun Hussein on Malaysia (UTHM). It operates on a small scale level and use renewable feedstock such as palm oil and used cooking oil, which are widely available in Malaysia. Biodiesel is produced using the transesterification process, allowing students to observe and understand each stage of production in a controlled environment. The main purpose of the FKMP Biodiesel Plan is to support teaching, learning, and research related to renewable energy and sustainable engineering. It provides hands-on experience for engineering students in biodiesel production and processing. The plan also aims at improving biodiesel qualities, increasing production efficiency, and promoting environmental friendly alternatives to fossil fuels in line with green technology and sustainable goals. Now, let's go to the important part, which is thermodynamic application in the plant. This application divided into three things, which is the first one is thermal management using heat exchanger. Heat exchanger are used to control temperature during biodiesel production. They help heat raw vegetable oil and methanol to require reaction temperature in about 60 degrees Celsius and cool the biodiesel and glycerin after the reaction before we put it into the storage. This process is based on the first law of thermodynamic, where energy balance is applied to a steady flow heat exchanger. The main focus is on the heat transfer needed to raise or lower fluid temperature, while changes in kinetic and potential energy are ignored. The second one is transesterification in mixing chambers or reactors. Transesterification is the main reaction in biodiesel production and takes place inside reactors that act as a mixing chambers. The application is on the vegetable oil, alcohol, ethanol, and a catalyst are mixed together in the reactor. These mixings allow the oil to react and form the biodiesel and glycerin. The principle of the thermodynamic is the reactor is treated as a steady flow mixing system. The law of conservation of mass and energy are used to make sure that the total mass and energy entering the reactor are equal to the total mass and energy leaving it. And the third one is the fluid transport and pressure control using pumps. Pumps are used to move liquids throughout the biodiesel plant. The application is they transfer raw oil from the storage tanks to the reactor, move biodiesel and glycerin to a purification units, and pump it to the final biodiesel into a storage tanks. The pump uses external power, which is the shaft work, to increase the pressure of a liquid so it can flow through the pipes and equipment. The energy supplied to the pumps helps overcome frictions and allows the fluid to move to a higher pressure or elevation. That's the that's the end of the thermodynamic application in appliance. Now I'm gonna pass it to my friends.
Assalamualaikum. My name is Muhammad Ihsanofal bin Muhammad Zuan. My matrix number is AA241277 and I will be presenting about equipment and process. So the first one is feedstock storage tank. It is used to store vegetable oil, animal fat, or use cooking oil. The second one is methanol storage tank. This tank is specialized industrial tank that was designed for the safe storage of alcohol that was gonna be used for the transesterification process. The next one is catalyst storage and dosing system. This system will accurately measure and inject catalyst into the reaction process. The fourth is heat exchanger. Heat exchanger is used to preheat the oil and methanol to the required reaction temperature. The next one is mixing or reaction tank. This is the most important part of the plant because at this tank there will be chemical reaction that take place under controlled heat and pressure. The next one is agitator or stirrer. This is a mechanical mixing devices installed within the reactor to ensure an even mixture of oil, alcohol, and catalyst. The next one is filtration unit. This is the final stage filter where all the biodiesel will be ensured to meet the purity standard by removing the fine particulate matter. And the next one is pump and piping. This is the infrastructure that transfer all the liquid between different part of the plant. The next one is storage tank for final product. This is where the finished biodiesel and separated glycerol byproduct will be stored before shipment. And the last one is cooling tower. A cooling tower is used in a biodiesel plant to remove excess heat that was produced in the biodiesel making process, and it will maintain safe and stable operating temperature. The next one is 5.2 operational process. For step 1 is feedstock preparation. Raw oil such as palm oil or used cooking oil are collected and filtered to remove impurities like food residue, dust, or water. This step is important because it will ensure a clean starting material for efficient chemical reaction. The next step is preheating. The filter oil is preheated to around 60 Celsius using heat exchanger. It will lower oil viscosity and improve reaction efficiency during transient esterification process. For the next process is catalyst and alcohol preparation. In this process, methanol or ethanol is mixed with a catalyst, usually sodium hydroxide or potassium hydroxide, to form an alkoxide solution. The purpose for this step is that the catalyst will promote the conversion of triglyceride in the oil into biodiesel and glycerin. For step 4 is transesterification reaction. In this process, the preheated oil and catalyst alcohol mixture are fed into a reactor, which is known as mixing chamber. The mixture is then stirred continuously and maintained at a reaction temperature, which is 60 Celsius, for 1 to 2 hours. The chemical principle for this step is that the triglyceride will react with alcohol to form biodiesel and glycerin. This is the core step where biodiesel is produced. The next step is the separation process. After the reaction, the mixture is allowed to settle in a separation tank. Biodiesel, which is less dense, will float on top, while glycerin, which is denser, will settle at the bottom. This process is important so that we can efficiently separate the two products for further processing. Biodiesel will continue to be used, while glycerin will be used to make other products. And the last step is storage. Purified biodiesel will be stored in a dedicated tank at a room temperature. It will be ready for distribution or testing. Storage unit is important to ensure safe storage and maintain fuel quality.
Assalamualaikum. My name is Muhammad Akmal Hazim bin Hazuli. My matrix number is AA240504, and I'll be presenting about safety considerations in biodiesel making process. For the first one is handling of flammable chemicals. As we know, biodiesel plant use a lot of chemical elements such as methanol and ethanol. So these elements are highly flammable and toxic. so that a proper storage, ventilation, and use of personal protective equipment (PPE) are essential to prevent fires and health risks. The second one is chemical exposure and burns. Catalysts such as sodium hydroxide or potassium hydroxide are corrosive. So, a direct contact can cause skin burns or eye damage. So, proper training and safety procedures must be followed. The third one is pressure and temperature control. Reactors and heat exchangers operate at elevated temperatures. Any faulty equipment or poor monitoring can lead to functional failure such as leaking that can cause an explosions. So that making regular inspection and safety controls are necessary. And for the last one is fire and explosion risk management. The presence of flammable alcohols and hot processing equipment increases the risk of fire or explosions. So, safety equipment such as fire extinguisher, emergency shutdown systems, and clear evacuation procedures must be in place. The next one is environmental considerations in biodiesel making process. First, wastewater disposal. The biodiesel washing process produces wastewater that contains methanol and other chemicals. This water cannot be released directly into drains or rivers. It must be treated first to remove harmful substance. Proper treatment could help protect water quality and aquatic life. Second is glycerin byproduct handling. Glycerin is produced as a byproduct in the biodiesel process. Careless disposal of glycerin can lead to environmental pollution. It can be reused, purified, or safely disposed of by following proper regulations. Good handling of glycerin could help reduce waste and protect the environment. Next, air pollution control. Alcohol vapors, especially methanol, may be released during the biodiesel process. These vapors can affect air quality and human health if not controlled. A proper ventilation systems and seal equipment can help to reduce the amount vapor released. This helps keep the working area and surrounding environment safe. The last one is sustainable raw materials, making biodiesel from used cooking oil instead of fresh vegetable oil is good for the environment. By recycling old waste, we stop food from being turned into fuel, which helps keep grocery prices down. It also protects our forests because we don't need to clear more land for farming. Essentially, we are turning a massive waste product that usually clogs drains into a clean energy source.
Assalamualaikum. My name is Adi Farhan bin Muhammad Nazran, and I will be presenting section 7.0, which covers the challenges and innovation observed at the FKMP biodiesel plant. So, one of the main challenges is process control. Industrial processes need accurate control of temperature and operating conditions, as small changes can affect the quality of the final product. Even small variations can affect the reaction efficiency and the quality of the final biodiesel product. So for another challenge is energy efficiency. So during plant operations, some energy is lost, mainly in the form of heat from equipment such as reactors and heat exchangers. This reduces the overall efficiency of the system and increases energy consumption. Other than that, safety risks are also an important concern. The use of inflammable chemicals such as methanol, high operating temperatures, and mechanical equipment can pose hazards if not handled properly. Therefore, strict safety procedures and monitoring are essential. In addition, waste management presents a challenge. The biodiesel process produced by a product and wastewater that must be treated carefully to prevent environmental pollution. Finally, equipment maintenance is necessary to ensure smooth and continuous operation. Regular inspection and maintenance help prevent equipment failure and production downtime. To address these challenges, several innovations have been implemented at the plant. Firstly, monitoring and control systems such as temperature and pressure sensors are used to ensure stable and safe operating conditions. Secondly, process optimization is applied by adjusting operating parameters to improve efficiency and reduce energy losses. The plant also practices material recovery, where byproducts like glycerin are recovered and reused, helping to reduce waste and operating costs. In terms of safety, improved safety practices are implemented through proper training, clear procedures, and the use of personal protective equipment. Lastly, environmental control measures such as wastewater treatment and emission control systems are used to minimize environmental impact and support sustainable operation. Thank you. In conclusion, the FKMP biodiesel plant visit connected classroom theory with industry practice. We observed thermodynamic principle, biodiesel making process, and understood the importance of safety, sustainability, and teamwork. The experience prepared us to tackle real-world engineering challenges in a renewable energy responsibly. That's all from us. Thank you.